All right, let's dive into this self-optimizing system stuff
Mhm.
using open source large language models like Llama. It
Yeah.
seems like from your notes, you're really interested in creating a system that learns and adapts over time.
Yeah.
And you want to do it without spending a fortune, right?
Yeah, exactly. And the really cool thing is open source LLMs have kind of made this sophisticated AI possible for, a lot more people. It's not about static models anymore. It's about systems that actually evolve
Yeah,
and, get smarter with every interaction.
that's awesome. So how do we actually make this happen? I saw in your notes that you mentioned fine-tuning. It seems like that's really important for a self-optimizing system.
Oh, absolutely. Fine tuning is like, when you get a really nice suit, but it's like off the rack. You start with a great base model like Llama that has, a good understanding of language already. Then you fine tune it with a specialized data set,
Mm,
to make it excel at something specific, like analyzing financial data or maybe translating languages with like super high accuracy.
gotcha. And that's where Llama 3.1 comes in, right? I mean,
Yeah.
it's open source,
Right.
so no vendor lock-in. Plus, it saves a ton of money compared to those proprietary models.
Exactly. Llama 3.1 is a great foundation. But for a truly self-optimizing system, you need a few more things. First, you need a really good data pipeline. Think of it like a system that constantly feeds your LLM fresh information, so it can keep learning and adapt to like new trends and data.
So it's like making sure your AI has a healthy diet for optimal growth and all that.
Exactly. And then we need a feedback mechanism. This is how your system learns from its mistakes. It's like giving your LLM a performance review. You can use user feedback, A/B testing results, or other kinds of evaluation to like help the system improve.
Okay, so we've got this like super smart LLM. It's constantly learning from new data and feedback, but all this learning,
Yeah.
it's got to take a lot of computing power, right? What about the training infrastructure?
Yeah, for sure. You'll need the right tools for the job. Things like GPUs for the processing power and specialized libraries like Hugging Face transformers. They're great because they have like pre-built architectures
Right.
and tools for working with LLMs. But don't worry, you don't need a whole server farm.
Right. You mentioned cost efficiency before, and I saw a bunch of really clever strategies in your research to keep those costs down. One that stood out to me was quantization.
Ah, yeah, quantization is kind of like compressing a big file.
Hmm.
But without losing too much quality, it shrinks down the model's weights, making it smaller and faster. What's amazing is you can often keep most of the performance, even with these smaller models.
You get a leaner, faster system that's still super capable, perfect for someone without, a bottomless budget.
Exactly. And if you need to work with even bigger models or like huge data sets, that's where model parallelism comes in. It's like having a team of experts working together on a tough problem. You split the model across multiple GPUs or TPUs so you can train and run it efficiently, even on less powerful hardware.
That's pretty smart. So we've got the basic building blocks now. We've got Llama data pipelines, feedback mechanisms, and some cost-effective strategies for training. But where do we actually run this whole system?
That's a great question. There are some exciting options to think about, like cloud platforms that are built specifically for AI workloads. And then there's this like mind-blowing potential of peer-to-peer AI networks where people can contribute their own computing power to like collectively run large models.
Yeah, and one that really stood out in your research was RunPod. It's a cloud platform that's like made for AI workloads, and it could be way cheaper than using, the big cloud
Yeah,
providers.
RunPod. It seems like everyone's using it these days, especially if they're on a tight budget. What makes it so great?
Well, with RunPod, you rent GPUs by the hour,
Yeah.
so you're only paying for what you actually use, which is awesome, especially if you're not running your models all the time, 24/7. A lot of the big cloud providers, they try to lock you into these long contracts where they'll charge you even when you're not using the resources. That flexibility is key when you're like experimenting and trying to optimize your system. Did your research look into how to get Llama 3.1 working on RunPod?
It did. First thing, you need a RunPod account, obviously,
Yeah.
and you got to have some funds ready to go. Then you would install Docker on your computer. Docker's amazing for packaging and running applications in these things called containers. It's like the best way to get Llama 3.1 running on RunPod.
Docker, it's like putting your AI in a little box and shipping it off to wherever it needs to go.
Exactly. So once you've got Docker set up, you create a GPU pod on RunPod. A pod is basically like a virtual machine that's all set up for AI. You pick the type of GPU you need, and the operating system RunPod makes that whole process pretty easy.
So you've got your RunPod account, you've got Docker installed,
Yeah.
and you've got this like brand new GPU pod just waiting for you. What happens next?
All right, so you'd connect to your pod using SSH. It's a secure way to, access a remote computer. Then you download and install Llama. It's a tool made for running large language models. Basically, a Llama just makes it super easy to manage and work with Llama 3.1 on your RunPod pod.
Oh, Llama. It's like a shepherd for your Llama, huh? But what if you wanted like a more visual way to work with the model? Something a little more user-friendly.
Oh, in that case, you'd want to use OpenWebUI's chat interface. It gives you a graphical interface, so you can actually chat with your Llama 3.1 model. It's a lot more intuitive than using a terminal.
A chat interface. Now that's something I can get behind. It's like having a conversation with your AI.
Exactly. It makes it so much easier to test and interact with your model.
Okay, so RunPod seems like a pretty good option for setting up this whole self-optimizing system.
Yeah.
But your research also looked at those peer-to-peer AI networks, right? Like Petals and HiveMind, where people can team up and use their computers to run these massive models. That idea of a decentralized AI supercomputer is pretty wild.
It is. They're still pretty new, but these networks could totally change how we access AI. Imagine a world where anyone can contribute to these cutting-edge AI models and benefit from them too, no matter how much money they have. It'd be like a global brain for AI.
A global brain. That's a great way to put it. So how do these networks actually work? Are we talking about like a bunch of computers all wired together?
It's a little more complicated than that. In a system like Petals, you'd run a piece of the large language model on your own computer, and then the platform connects you with other people who are doing the same thing.
So it's like crowdsourcing the computing power for AI. Instead of relying on one super powerful machine,
Yeah.
you're spreading the work across a whole network of computers.
Exactly. And it's a really cool approach with some potentially huge advantages.
Like what?
Well, for one, peer-to-peer networks can be way more cost-effective than the traditional cloud platforms. You're pooling resources with other people instead of paying a company to use their hardware, which can save you a ton of money.
Right. It's like the sharing economy, but for AI.
Yeah.
What other advantages are there?
Well, they can also be more resilient to outages. Like if one computer in the network crashes, the others can pick up the slack and keep things running smoothly, which is super important for things that need to be available all the time.
Yeah, that's a big deal compared to relying on a single computer that could fail. What else is there?
They can also offer better privacy than using those centralized cloud platforms. Your data is spread across a bunch of different computers, so it's much harder for one company to access it or control it.
So we're talking about saving money, better reliability, and more privacy. It sounds like peer-to-peer networks have a lot going for them. But I imagine there's some challenges too,
Right.
before they become like the standard way to run AI systems.
Oh, for sure. One big challenge is bandwidth. To train and run these large language models, you need to move a lot of data between the computers. And that can be a problem with regular internet connections.
Yeah, getting all that data to flow smoothly
Right.
across a network like that.
Yeah.
Can't be easy. What other challenges are there?
Latency can also be an issue. That's like the time it takes for data to travel between computers. It can slow down the training and processing.
So you need both speed and reliability.
Yeah.
Got it.
Yeah.
Any other concerns?
Well, security is obviously a big one. When you're working with a network like this, you got to make sure the data and the calculations are protected from, hackers, and that the whole system can't be easily messed with.
These are all really important points. It sounds like peer-to-peer AI networks have a ton of potential, but there are definitely some technical things to figure out before they become the go-to solution.
Absolutely. But I think as these platforms get better and the technology behind them improves, we're going to see a big shift towards this kind of decentralized and accessible AI.
Yeah, definitely something to keep an eye on. But let's switch gears for a minute and go back to something you mentioned before, Retrieval-Augmented Generation, or RAG. You said it's a way to make LLMs even smarter. Can you explain that a bit more?
Sure. So we've talked about how powerful LLMs like Llama 3.1 are, but they only really know what they were trained on. It's like having a brilliant student who's only ever read textbooks. They have a lot of knowledge, but they don't have a lot of real-world experience,
Yeah, that's a perfect analogy.
Yeah.
So that's where Ari comes in.
Exactly. RA takes that super smart LLM and it connects it with a retrieval system, like a search engine. So the LLM can access way more information. It's like giving that student a whole library. So they can pull in real-world examples and context.
So instead of just spitting back what it already knows,
Yeah.
the LLM can go out and find new information to give better answers. But how do we actually make ARG work? Are there special tools for that?
Oh, yeah, there are. One that's really popular is LangChain. It's a framework that makes it easy to connect LLMs with retrieval systems. It's like having a toolkit specifically for building RAG applications.
LangChain, yeah, I've heard of that one. Why is it so good for Argy?
Well, for one thing, LangChain works with a ton of different LLMs,
No.
including Llama 3.1, so
Uh-huh.
you can use whichever model you want for your RG system.
Nice. Flexibility is always a good thing.
Yeah.
What else makes LangChain stand out?
It also connects to a bunch of different retrieval systems, like ElasticSearch, FAISS, even those simple vector databases, so you've got a lot of options for picking the right system for your
So
needs.
you can customize it based on what kind of data you're using.
Yeah.
That's awesome. What else makes LangChain so great?
Well, it makes it really easy to manage the whole RAG pipeline. You can
Yeah.
lay out all the steps involved in taking a user's question, finding the relevant info, and then generating a response, all within a single framework.
Wow, so LangChain handles all the complicated stuff.
Yeah.
You could just focus on, like, the logic of your ag system. Speaking of retrieval systems, you mentioned Elasticsearch, FAISS, and vector databases. Can you tell me a little bit more about those?
Sure. So Elasticsearch, it's a powerful open source search engine. It's really good at indexing and searching like huge amounts of text data. Super scalable too, so you can use it even with massive data sets.
So if you're working with a ton of documents, Elasticsearch can help you find what you need.
What about FAISS? Is that
Hey,
different from Elasticsearch?
yeah, Facebook AI Similarity Search. It's a library that's built for finding similar things in huge data sets, especially those with high-dimensional vectors.
Vectors, we always hear about those with word embeddings. How do they fit in with retrieval systems?
hmm Well, you can use techniques like word embeddings to turn text documents into these vectors, which are basically just mathematical representations of the data. Then you can store those vectors in a special database called a vector database. And you can use algorithms to find documents that are similar to a given query.
So instead of looking for exact keywords, you're searching for documents that have similar meanings, even if they use different words.
You got it. Vector databases are really good at capturing the meaning of text, which
Right.
is super important for building like really sophisticated RAG systems. So it's like taking search to a whole new level. It's about understanding what the user actually means. This has been amazing. We've covered so much. We talked about the basics of building self-optimizing systems with open source LLMs. We looked at ways to keep the costs down. And we even touched on those futuristic peer-to-peer AI networks and the power of RAG.
I know, right? It's a really exciting time to be working in AI. All these open source tools are making these super advanced systems accessible to, like, everyone. And who knows what we'll be able to do in the future.
Well, now you've got a solid plan and all the knowledge you need to start building your own self-optimizing system. Just remember, stay curious, keep learning, and embrace the ever-changing world of AI.
This deep dive has been super helpful. I can't wait to put all of this into practice.
And we can't wait to see what you create.